Okay, now let's learn how to use the standard normal distribution table. So our target is from the table, you have to look up for 1.67. Okay, now the standard normal distribution is a specially designed table that gives you the lower tail probability. For example, if you look up for from the table, if you look up for 1.67, okay, so you are going to get the area which is the left side of the 1.67. So 1.z equals to 1.67 from the table will give you this area, okay? But is this the area that I'm looking for? Of course no. Why? Because the question here is probability of z is greater than 1.67. So if the table gives me the area up to 1.67, if the question requires the area above the 1.67, how are we going to find the answer? It's very easy. Why? Because I told you that the whole area under this curve is what? The whole area is 1. So if you are looking for the upper tail area, so this is our target, right? But the table gives us the area which is the left side of 1.67. So in order to find the area which is the right side of the 1.67, so all you have to do is look up for the 1.67 from the table and deduct this from the 1, and you will get the area which is the right side of the table. So all you have to do is here, so you have to go to the standard normal distribution table, so and then you have to find 1.6 from the left side of this table, and you have to see the second decimals at the top portion. It starts from 0.00, and then it's 0.01, it's 0.02, and goes to 0.09, okay? And then since we have the z, since our z value is 1.67, so you have to find the 1.6 on the left side of the table, and you have to find the 0.07 from the top part of the book, okay? Then you have to cross here, and you have to read off whatever written here, okay, for the 1.67. So let's find this value from the table. Okay, see here, this is the standard normal distribution table. It's a specially designed table. I'll show you here just a second. You have this in your books, okay, or you can Google it. As you see, there are two parts. On the left side we have the negative values. On the right side we have the positive values. Since our z value is positive, so we have to look up the number, the value from the right side of the table. And one more important thing here is always look at the shaded area, okay? Because sometimes there's a possibility that standard normal table is not giving you the lower tail probability. Okay, sometimes it gives you the upper tail, but in most of the cases, this standard normal table will always give you the area which is the left side of whatever you are looking for. Okay, so since we had 1.67 and z value, so you are looking for 1.6 here, okay, and you are looking for 0.07 from here. So you have to, let me find the value, 1.6 here, 7 is here, so it is 0.9616, okay? So it is it is 0. Okay, I lost the place. See, I'm getting older. So 1.67 is 67 is 1.09525, 0.9525, okay? So you have to write this down. Okay, where was our so it is here. The area on the left side of the 1.67 is here. So when you look up for 1.67, you are getting this area 1.67. So it is 0.9525. Am I right? One more time. Yes, 1.67 is 9525. So it is the area on the left side of the 1.67. Okay. So how are we going to answer the question? So the area above 1.67 is going to be 1 minus 0.9525, and which is let's calculate it. So it is 0.0475, or it is 4.75%. Okay, so the answer of the question here is, what was the question? What is the probability that on any given day the sale of bread is greater than 75? Is 4.75%. Okay. Okay, let's let me tell you something important here. So in this kind of problems, the most important thing here is, so you have to transform everything from normal distribution to the standard normal distribution. Why? Because once you have the standard normal distribution numbers, then you can use this table. So you don't have to take the integral, you don't have to deal with the advanced calculus formulas, okay? So that's why you have to convert everything from normal distribution to the standard normal distribution. How? By the transformation formula. What was the transformation formula? I gave you the transformation formula. The transformation formula is z equals to x minus mu divided by sigma. So this is the formula that you have to remember at all times. Standard normal variable z equals to x. X is the continuous random variable, minus mu. Mu is always given, divided by sigma. Sigma is always given. Why? Because this must be given. X is distributed normally with mu and sigma. So this is the given value. This is the normal distribution. This is the continuous random variable. But in order not to use the advanced calculus formulas, we are transforming everything from here to a standard normal distribution. Why? Because once we have the standard normal distribution, then we can use the table. Which table? This is the table. Okay, so this table has two parts. One side we have the negative numbers, on the other side we have the positive numbers, and we are using two decimal points, two decimal numbers. Okay, so on the one edge of the table you have the one decimal, and at the top portion, top edge of the table, you have the second decimal place. Okay, so in order to find, for example, 1.67, so you have to find 1.6 from here, and since the second decimal is 7, 1.67 is the cross of these two row and columns. Okay, whatever written here is the value, which is 0.9525 is the value for 1.67. Okay. Okay. Now let's see some other examples.